This tracks global electric vehicle production. China now produces 73 to 75% of all EVs, accounting for over 60% of global sales. Domestically, the shift is even more pronounced. New energy vehicles have officially crossed the 55% threshold for all new passenger car sales. This growth is occurring despite significant trade barriers. The United States has enacted 100% tariffs on Chinese EVs, while the European Union has imposed duties reaching 35.3%. Even with these international restrictions, Chinese EV exports surged past 1.25 million units in 2024. This lead results from a systematic redesign of EV engineering and a global export strategy that legacy automakers are currently struggling to counter. Competing in the modern EV market requires manufacturing on a massive scale. Powering that scale is a broad industry shift away from traditional nickel, cobalt, manganese batteries toward lithium iron phosphate, or LFP, technology. Currently, Chinese manufacturers maintain a near monopoly on this specific LFP chemistry. Traditional structural battery packs typically cluster cylindrical or prismatic cells into individual modules, which are then installed into the chassis. BYD's Blade battery discards the modular standard. Long, blade-like cells integrate directly into the structural frame, increasing volumetric energy density and reducing thermal runaway risks. Additionally, thick physical underbody protection layers prevent cell puncture during impact. By combining LFP chemistry with this cell-to-body integration, Chinese OEMs can produce vehicles that are cheaper, more rigid, and inherently safer than their legacy competitors. Rapid consumer adoption depends as much on refueling infrastructure as it does on the vehicle itself. NIO's battery swapping strategy focuses on mechanical speed to eliminate wait times. In this system, a depleted battery is mechanically swapped for a fully charged one in under 3 minutes, bypassing the time required for a traditional plug-in charge. Running parallel to swapping is the rollout of high-speed 800-volt charging architectures, such as the LFP systems developed by CATL. These systems can achieve 320 miles of range from a 5-minute charge. Developers are now integrating automated robotic charging arms at 600 kilowatt terminals to facilitate these speeds without human intervention. To support this rollout, the government has mandated a target of 28 million public and private charging units by 2027. The long-term objective is a 1-to-1 ratio of vehicles to charging piles across the country by 2030. This aggressive infrastructure scaling systematically removes the primary charging bottleneck for mass-market buyers. Manufacturers are also constrained by strict government caps on the electricity consumption per kilometer for all passenger EVs. Vehicles that exceed these efficiency limits are legally barred from sale in the domestic market. These caps force a focus on aerodynamic optimization and structural weight reduction, rather than relying on larger, heavier battery packs for range. The BYD seal is a direct result of these engineering constraints, designed to compete directly with the Tesla Model 3. In many markets, the seal undercuts the Model 3 on price, while offering more standard hardware features. Features like multi-screen layouts, executive massage seats, and over-the-air updates come standard in these smart cabins. These vehicles also integrate advanced driver assistance suites, using LiDAR and radar arrays for autonomous navigation and automated parking. Standardizing these premium features forces legacy automakers to compete on overall ecosystem value, rather than driving dynamics alone. This competition is driven by over 60 active domestic EV brands fighting for market share. The resulting price war has pushed entry-level prices for some models below $15,000. This chart tracks the financial cost of that competition: margin compression. Profitability is declining across the entire industry. Even brands with high-performance technology struggle to maintain consistent profit margins under these pricing pressures. While these wars strain short-term profits, they produce highly efficient manufacturing systems capable of undercutting global competitors. While the United States and the European Union maintain high tariff walls, Chinese manufacturers are pivoting their export strategy. Manufacturers are shifting volumes toward high-growth regions in Latin America, Southeast Asia, and the Middle East. To bypass import duties permanently, these companies are building full-scale production facilities directly within those target regions. BYD's manufacturing plant in Brazil is a prime example of this localization strategy. Establishing these regional hubs allows Chinese OEMs to capture the global south, positioning them to approach Western markets from the outside in. Government planning in China currently extends to the year 2035. By that date, pure battery electric vehicles are mandated to become the mainstream of all new vehicle sales. Executing this transition requires the coordination of global R&D and production bases. This growth is the product of vertical integration and proprietary LFP technology, rather than the historical model of low-cost labor. It is sustained by rapid infrastructure scaling and the expansion of local production hubs worldwide. These factors have shifted the competitive landscape of the global industry, defining a new set of rules for the future of transportation.